Sorry. So today we will cover few basic things which are very important. Say DC and AC. DC and AC. DC voltage, AC voltage, DC current, AC current, right? How do you define AC? How do you define it? The value of AC changes with respect to time. Correct? So, instantaneous value if you take at different points or different time intervals, it will be different. So, it is alternating or changing. Whereas DC, how do you represent DC? DC, straight line. Yes, with a straight line. Say 5 volts. And here it is also 5 volts minus 5 volts. So now, how do you define DC? How do you define DC? You know it is straight line, but any definition? Here the value changes with respect to time, there the value is fixed. Or AC signal is the signal whose average is 0. Take the average of this and get 0. Correct, sir? Because positive will cancel the negative. This plus this one is 0 by 2. Here average is non-zero. Average is non-zero. Fine. In previous class, we have seen diode, how it behaves when it is forward biased, reverse biased, then what the diode can be replaced by. It can be replaced by a voltage source followed by a resistance. In practical scenario, in practical diode, okay, and reverse bias, it can be replaced by simply a resistance. So RF forward resistance of the diode will be in terms of ohms, whereas reverse resistance of the diode will be in terms of mega ohms or even up to giga ohms. Okay, so this is practical diode. This is forward bias. This is reverse bias. Today, what we will do is study the applications of diode. First application we can take rectifier. Rectifier. How do we define rectifier? How you define rectifier? Feeling like we have heard somewhere but not remembering now. Rectifier, transformer, there, half wave, full wave, what is rectifier? Rectifier is a circuit which will convert zero average signal to non-zero average signal. If you tell rectifier converts AC to DC, it's not 100% true. Okay. Because rectifier alone cannot convert I hope you know what is transformer. You know what is transformer? What it is? Is it amplifier? Then this is step down. What is the difference between step up and step down? What is the difference between step up and step down? Which is step down? First one is step down. Step down transformer, step up transformer. So if I say if the number of turns, okay, here it is 10 and here say it is 100, assume here it is 100 and here it is 10. Okay? So if I give say 230 volts here and if I give 23 volts here, what will I get the other side? You should be knowing one formula. No? Nothing? So what is N1? Number of turns in the primary side of the transformer. N2, number of turns in the secondary end of the transformer. V1, voltage at the primary side. V2, voltage at the secondary side. So if you equate that, what will you get here? You have three values. You have V1, you have N1, N2. We need V2. V2. How much? How much? 23. Here we have 23. So here how much will we get? 230 volts. Correct? Now my question is, consider this case, step up transformer. 23 volts is becoming 230 volts. So can I call transformer as an amplifier? Oh my God. ಇದನ್ನು ಯಾವಾಗ ವಿಚಾರ ಮಾಡಿದ್ರಿ ನೀವು? ಮೊದಲ ಆಂಪ್ಲಿಫೈ ಆಗತ್ತಲ್ಲ, ಮತ್ತೆ ಆಂಪ್ಲಿಫೈರ್ ಹಾಕಬೇಕು. ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ ಹಚ್ಬೋದಲ್ಲ ಎಲ್ಲ ಕಡೆ. $23 becoming $230, 10 times. Amplifier? Yes or no? Say my name transformer. Why not amplifier for this? It is not an amplifier. It can't be amplifier. Why it can't be amplifier? Because if I say that 23 volts is becoming 230 volts, then if I have say 10 ampere current here, that will be converted to 1 ampere. So the amplifier the transformer cannot act like amplifier because it is increasing the voltage, then it is reducing the current. So power is same. Power is same. Okay. What is amplifier? It boosts the power. So here what it is doing? It is increasing voltage but decreasing the current. Finally power is same. This cannot be called as amplification. Important. Interviewer may ask you. Okay. So amplifier is a circuit which will increase the strength of the signal or power of the signal. If current or both. Yes, it is an amplifier. But here it is increasing, but it is decreasing, so it's remaining same. Okay. So transformer is not amplifier, not at all. I thought you people know something about transformer. So, what is the most frequently or most important application of transformer? What is the yes, electricity, power generation, all use ಮಾಡ್ತಾರೆ. ಹೌದಾ? So one thing I'll tell you. Say I have power generation here. Okay, so this is power generation. Power is generated and it is transmitted to your home. It is transmitted to your home. Correct? Now, there will be a transformer here, and there will be a transformer near your home also. Near your surrounding, there will be one transformer. Okay. Here is also a transformer, here is also a transformer. What they are doing actually? Why it is required? Yes, it will definitely step up and shut down 100%. Okay, it will step up and shut down. But why it is required? Yes, 100% correct. Long distance traveling is there. So, what is our objective in stepping up, stepping down for longer distance? Any specific objective is there? If we don't do that, what will happen? We are almost near to the answer, but exactly no one has said it. What is P is equals to power formula? I to V. Or P is equals to I squared into R. Correct? So, power is directly proportional to I square. Power is directly proportional to I square. If you reduce I, P will be reduced. Correct? That is what we do here. So, we will reduce I. Reduce I means we will do this. Say 230 volts. 230 volts. It is generated. It is stepped up. Okay. So 230 volts is converted into example I am telling 11,000 volts. Then he ಮಾಡಿಬಿಟ್ರೆ ವೋಲ್ಟೇಜ್ ಜಾಸ್ತಿ ಮಾಡಿದ್ರೆ ಏನಾಗ್ತದೆ ಕರೆಂಟ್ ಏನಾಗ್ತದೆ 23 to 230 ಮಾಡಿದೆ ಕರೆಂಟ್ ಏನಾಗ್ತದೆ ಕಡಿಮೆ ಆಯ್ತು ಹೌದು ಸೊ ಕರೆಂಟ್ will come down and then we will transmit. So this transmission line ಏನಿರ್ತದಲ್ಲ it has some resistance. If I is less, my power loss will be less. If the transmission ಆಗ್ತಿರ್ತದಲ್ಲ, so there will be some transmission losses. ಹೌದು transmission loss ಆಗ್ತದೆ. If transmission ಮಾಡಲಿಕ್ಕೆ ನಮ್ಗೆ ಬಹಳ ಲಾಸ್ ಆಗ್ಬಿಡ್ತಂದ್ರೆ ನಮ್ಮ ಮನೆಗೆ ಬರ್ಲಿಕ್ಕೆ ಬಹಳ ಕಡಿಮೆ ಉಳಿದ್ಬಿಡ್ತದೆ. So So we have to reduce the transmission loss. Therefore, step up transformer is used before transmitting. After transmitting, step down. So the money can order with you. In Kopri, in Matter, Khatra, danger. So that is nothing but 11K to 230 volts. Suppose we have ಮಾಡಿಲ್ಲ 230 to 11,000 ಮಾಡಿಲ್ಲ current ಎಷ್ಟು ಜಾಸ್ತಿ ಇರ್ತದೆ. More current is there. So more current, so more power loss. So more power loss means efficiency will be down and we will receive less power. Okay, so therefore to minimize the power loss, we use step up and step down. Okay. Now when we step down, the current will increase. The current ಕಡಿಮೆ ಮಾಡಿ ಕಳಿಸಿದ್ವಿ, ಇದು ವಾಪಸ್ ಕರೆಂಟ್ ಜಾಸ್ತಿ ಮಾಡ್ತೀವಿ. ಎಲ್ಲ ಕಡೆ ಇರ್ತದೆ ಅದು. Everywhere we have transformers. ಅರ್ಥ ಆಯ್ತು? Yes. ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ ಭಾಳ ಟೈಪ್ ನೋಡಿರೋ ರೆಕ್ಟಿಫೈಯರ್ ಇರ್ತಿಲ್ಲ. ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ ಯಾಕೆ ಹೇಳಿದ್ರೆ ಫಸ್ಟ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ ಇರ್ತದೆ ರೆಕ್ಟಿಫೈಯರ್ ಒಳಗೆ. So we will go with the rectifier. So the first thing is transformer in a rectifier. Say you give 230 volts. Okay, you have say 100 turns here, 10 turns here. So you get 23 volts. I am drawing a half wave rectifier. So this is silicon diode. Okay, so I think you know what is the working of this. So doing positive half will be like this. So diode will be forward biased. So if I have 23 volts and minus 23 volts in input, okay, output ಏನು ಬರ್ತದೆ ಅಂದ್ರೆ ಎಷ್ಟು ಬರ್ತದ 23 minus 0.7 volts. ಯಾಕೆ commission product. So I'll get the output 23 minus 0.7 volts. Output hinge bartala. Andilla. Negative half will be there or no? Will not be there. Why it will not be there? Because negative half cannot be passed through the diode because it will be reverse bias. So at this point it will become negative. Negative to positive, it is reverse bias, so it will act like open circuit. And at that time, whatever voltage is coming across this point, 23 volts will appear here. That is called as PIV, peak inverse voltage. Whatever voltage is coming here, that will be present at these two points. That is called as PIV, peak inverse voltage. Okay. Now there is something. This is AC signal. What is this signal? Like AC only. Here also up and down, here also up and down. This signal is AC or DC? AC or DC? take the average, it is non-zero. Take the average here, it is 0. So it is pure AC. This is pure AC. This is neither pure AC nor pure DC because it is not a straight line. And average is also not 0. So AC and DC both are present in this. Correct? So what rectifier has done? Now you can define rectifier. What it has done? It has converted AC signal to pulsating DC. This can be called as pulsating DC. Why it is called as pulsating DC? Because you can see pulses. You can see pulses. Okay. It is DC, but AC is present in it. Or rectifier converts zero average signal to non-zero average signal. If you tell this answer, interviewer also think, oh, what special answers they are giving. Zero average signal to non-zero average signal. Okay, next. So rectifier is a circuit consisting of transformer, diode. Okay, diode is the main component which does rectifier action, converts zero average signal to non-zero average signal or AC signal to pulsating DC. Step. So rectifier converts AC to DC, partially correct, not completely correct, because this DC is not pure. Next. Rectifier is present in all the chargers. You have mobile charger, you have laptop charger, and many appliances which require DC for charging, pure DC for charging. In that, rectifier is must. Okay, rectifier is really must. So actually, our aim is to get pure DC from AC. That is our objective. So first part is rectifier, which will help us little bit. Okay. Next, what we should do is we have ripples. These are called as ripples. AC contents are called as ripples. RIPPLES. Okay. So we want to remove these ripples. We want to remove these ripples. So how to do that? How to do that? Place something called as filter, capacitive filter. Okay. You might have learned only capacitive filter, correct? Or you have learned something else, some extra thing also about filters. Have you heard of L filter? This is C filter, capacitive. L filter, LC filter, CLC filter. You can place CLC filter also. This is CLC. CLC. Okay. Any filter. But what filter does? What normal filter does? Removes the unwanted things. What is unwanted now? What is unwanted? What is unwanted? AC is unwanted because our final aim is pure DC. So we want to remove the AC. Now, very interesting to know. Okay. Capacitor. Many people say capacitor passes the AC, blocks the DC. Hope you know. It blocks the DC and it passes the AC. Correct? How it does that? How it does that action? Everybody says capacitor, yes, passes the AC, blocks the DC. How? Don't know. How you do that? apply a DC to the capacitor, what it will do? It will charge up. It will charge up to what volts? It will charge up to 5 volts. It will charge up to 5 volts. Okay, so what will happen? Current will start flowing. Current will start flowing. I should not call it as current, I can call it as charges. So positive charges will come and sit here. Negative charges will come and sit here. Once it is charged up to 5 volts, no current will flow. No current will flow. No charges will flow. Once it is charged up to 5 volts, okay. So here the current is not flowing actually. We see initially charges flow and sit on plates of capacitor moving. Step. Other no current flows. Therefore, it is said that when there is no current flowing in the circuit, you can say capacitor is blocking the DC. Because I have applied DC here. Now what we will do? Now we will apply AC. So you take capacitor. Apply AC. What will happen? AC is passed by the capacitor. How it is passed? Tell me. How it is passed? This part is understood? Yes or no? So there is no current flow. Once the capacitor is charged, remove this. Now you tell me how the capacitor passes the AC. How it blocks the DC we saw. We have a mathematical equation also. That also you can see. The mathematical equation is XC is equals to 1 upon 2 pi FC. Where XC is the reactance of the capacitor. Reactance means what? Resistance. Just like resistance. Okay. So, if F is 0, what is the reactance? If F is 0, reactance is infinity. F is 0 for what? DC. What is F? Frequency. Why it is 0 for a DC? It is constant. It's constant line. No fluctuations. Okay, so mathematically also it is true. Because frequency of DC is 0. Okay, so you have put F equals to 0 in this. 1 upon 0 is infinity. XC is infinity means what? The reactance of the capacitor is infinity. Means what? Capacitor has infinite resistance to the DC. This is the meaning. Okay. Now come to AC. So it is very interesting to know how it passes the AC. Okay. I asked the same question to few of my students earlier. So they said capacitor will be like this, no sir? So capacitor will be like this. AC can jump like this and go. AC can jump like this and go. No. AC means what? First it will be plus minus. So when it is plus minus, be like this. But it is AC. So if this will not be continuous. Here next plus minus plus plus minus okay. So if plus after the next minus so it will flip. This will become like this. The next minus correct. So it will be minus and plus. So when this becomes minus, this becomes plus. Minus all minus here, all plus on this side. Correct. Next cycle one plus minus. One plus minus plus series minus. So again, finally when you look, il plus minus ಇದು ಯಾವ ಚೇಂಜ್ ಆಗ್ತಿದೆ ಅವಾಗ ಚೇಂಜ್ ಆಗ್ಬಿಡ್ತದೆ ಹೌದಲ್ಲ ಸೊ ಪ್ಲಸ್ ಇದಾವಲ್ಲ ಇಲ್ಲಿ they are being shifted to other side and minus is being shifted to this side. That means current is flowing. Again question arises how it flows, because in between we have dielectric insulator. Then how it flows? It flows first it becomes like this, all positives, all negatives. When this flips, this will go like this, this will go like this. So in pass agudilla current, but still we say current is flowing. Because why current is flowing? Because these are flipping, charges are flipping. This is how so beautifully the capacitor passes AC. Though we have dielectric in between or insulation in between, still it is passing AC. Why we say passing AC? Because charges are shifting. So simple. And even mathematically also, this is not zero. F is not zero. F frequency of the signal. Say frequency of this signal is 1 kilohertz. Then you put F equal to 1 kilohertz, we will not get infinity. We will get some finite value. That means reactance of capacitor to the AC is not infinite. It is some finite value. So it can pass the AC. Mathematically also proved, logically also proved. Now come back to a rectifier. We are in rectifier, and in rectifier what we have done? Place the capacitor. What capacitor will do? AC. We have AC and DC both. So what capacitor will do? For DC what it will do? So it will block the DC. For AC what it will do? Pass. Pass means AC will pass means it will come back. It will come back. Pass not DC it will not pass. DC cannot pass through it. So DC voltage will be stuck here. But AC passes. Therefore, when we see the voltage at these 2 points, which is our output point, we will measure DC is more compared to AC, but AC is not zero, because the AC is also flowing, but AC is not stuck here. Okay, so by placing the filter, our DC content will increase, AC content will reduce. The same is represented in this graph. When I place the capacitor, basically capacitor charges in action into positive character negative character, that is charging action. So capacitor will start charging. Okay, once it is charged maximum, this peak value, maximum value. Okay, then this is going down. So this also should go down. But capacitor cannot discharge immediately. It needs some time. So it will discharge slowly. It is discharging, but in the process of discharging, a new waveform has arisen. So it has not completely discharged. It was discharging, but again it will start charging. Again it will start discharging. So this part will go away. And I will be left with only this much. Like this. So this was our waveform. And now we are left with very less AC content. But still AC is there. How to remove that AC? How to remove this AC? Again, what we can do is you increase the value of R and increase the value of C, so that actually time is equal to R into C. So if you increase R and if you increase C, the time will also increase. What is time? Time to charge and time to discharge. So if you do this, increase the value of R and C in your circuit, what we can observe is, instead of this waveform, you see little variations. Very little variation. And again, if you increase R and C, okay, you will see almost straight lines. You will see almost straight line. But I have got straight line. I have increased R and C very high. R and C very high. I have got straight line. But still, this circuit can't be used directly in our charger. Though I am getting straight line, can't be used. Why it can't be used? Because this 230 volts is not fixed. Near your home, if you have digital meter. ಇರ್ತದ ನಮ್ಮಲ್ಲಿ ಒಂದು 10 ಕಂಬಗಳ ಒಂದು ಕಂಬ ಡಿಜಿಟಲ್ ಮೀಟರ್ ಇರ್ತದೆ, ಅಥವಾ ನಿಮ್ಮ ಅಪಾರ್ಟ್ಮೆಂಟ್ ಈಗೆಲ್ಲ ಡಿಜಿಟಲ್ ಮೀಟರ್ಸ್ ಬಂದವು, ಎಲ್ಲೋಗಿಲ್ಲ. ಜಸ್ಟ್ ಅಬ್ಸರ್ವ್ ಮಾಡ್ರಿ, ಅಬ್ಸರ್ವ್ ದಿ ಡಿಜಿಟಲ್ ಮೀಟರ್. 230 volts is not fixed. Some it changes. It becomes 236, it becomes 228, 232, 240. Fluctuations ಇರ್ತದೆ. ಸೊ ಇಲ್ಲಿ ಈ ಫ್ಲಕ್ಚುಯೇಟ್ ಆಗ್ತದೆ, ಈ ಹಿಂಗ್ ಸ್ವಲ್ಪ ಮೇಲೆ ಕೆಳಗೆ ಫ್ಲಕ್ಚುಯೇಟ್ ಆಗ್ತದೆ, ಇದು ಫ್ಲಕ್ಚುಯೇಟ್ ಆಗ್ತದೆ, ಈ ಲೆವೆಲ್ ಫ್ಲಕ್ಚುಯೇಟ್ ಆಗತೈತಿ. ಸೊ ಈ ಫ್ಲಕ್ಚುಯೇಟ್ ಆಗ್ತದೆ, ಇದು ಹಿಂಗ್ ಸ್ವಲ್ಪ ಮೇಲೆ ಕೆಳಗೆ ಫ್ಲಕ್ಚುಯೇಟ್ ಆಗ್ತದೆ. ಹಂಗ ಈ ಏನ್ ಸ್ಟ್ರೇಟ್ ಲೈನ್ ಬಂದದ, ಈ ಸ್ಟ್ರೇಟ್ ಲೈನ್ ಸ್ವಲ್ಪ ಸ್ಟ್ರೇಟ್ ಲೈನ್ ಐತಿ, ಬಟ್ ಮ್ಯಾಲ ಹೋಗೋದು ಕೆಳಗೆ ಹೋಗ್ತದೆ, ಮ್ಯಾಲ ಹೋಗೋದು ಕೆಳಗೆ ಹೋಗ್ತದೆ. Though it is DC, but DC is fluctuating now, which is not preferred for any of the appliances. Fixed voltage ಬೇಕು ನಮ್ಗೆ. ನಿಮ್ಮ ಮೊಬೈಲ್ ನಾಗ ರೇಟಿಂಗ್ ಇರ್ತೈತಿ 3.5 volts 3.5 volts ಬೇಕು ಚಾರ್ಜಿಂಗ್ ಇಲ್ಲ. ಒಂದ್ಸಲ 3.6 ಕೊಡ್ತೀವಿ, ಒಂದ್ಸಲ 3.4 ಕೊಡ್ತೀವಿ, ಮೊಬೈಲ್ ಹಾಳಾಗ್ತದೆ. Okay, so these fluctuations 3.5 or 3.4 or 3.6, these fluctuations should be removed, which can be removed by something called a voltage regulator using xenon diode.